January 1942. Winter winds cut across the quiet streets of Wilmington, Delaware, rattling windows and sweeping snow into drifts that clung to factory walls. Inside the Hercules Powder Company, a different storm raged. The rhythmic clatter of machinery mixed with the sharp tang of chemicals, a scent that burned the throat and lingered in hair and clothing. Workers in heavy coats and goggles moved with precise urgency, their breath fogging the air as they monitored vats of thick, white slurry. Outside, the world was collapsing. The Pacific Fleet lay reeling from Pearl Harbor. Across Europe, battlefields burned and gunpowder thundered. Yet here in America, the nation's munition stockpiles were perilously thin. Shells sat empty, bombs unarmed, rifles silent. Without rapid production, soldiers on distant fronts would face the enemy unarmed, and every delay could cost thousands of lives. But in these humming factories, an unusual solution was taking shape. Engineers and chemists studied vats of cornstarch, a simple kitchen ingredient, with the same gravity once reserved for nitroglycerin. What began as flour would soon become the lifeblood of an army. The first batches were about to roll off the lines. America's fight depended on them. By early 1942, the United States was a nation abruptly thrust into total war. The Japanese attack on Pearl Harbor in December 1941 had shattered illusions of safety. Ships had sunk at anchor, planes lay in smoldering craters, and over 2,400 American servicemen were dead. The shock reverberated across the nation, sending a surge of urgency into every corner of government, military, and industry. The U.S. was unprepared, not just in terms of trained forces, but in the very raw materials that fed its war machine. Among the most critical shortages was gunpowder, the fundamental ingredient of artillery shells, small arms ammunition, and explosives used across all theaters of war. Prior to the war, America had maintained modest stockpiles of gunpowder, enough for peacetime operations and limited overseas commitments. Factories like those of DuPont and Hercules produced explosives at a pace aligned with training exercises and domestic law enforcement needs. But this system had never faced the demands of a global conflict. Within weeks of entering the war, military planners realized that existing production lines could not keep pace with the sudden, explosive demand. Artillery shells, which had once been plentiful, were suddenly in perilously short supply. Infantry units trained with rifles but lacked ammunition. Bombers prepared for missions had only partial payloads of high explosives. The shortage was not a simple logistical problem. It was a technical challenge. Traditional gunpowder required a careful combination of nitrates, charcoal, and sulfur, materials that were themselves in limited supply. Nitrates came from overseas sources, particularly Chile, and shipping lanes were now threatened by Axis submarines and warships. Domestic nitrate plants had only a fraction of the capacity needed, and alternative sources, such as synthetic production, were still in early development. Meanwhile, the military's need for munitions grew daily. From the frozen training grounds of Fort Bragg to the tropical islands of the Pacific, every soldier, sailor, and airman depended on a reliable supply of explosives. Recognizing the urgency, the U.S. government convened emergency planning committees to assess industrial capabilities. The War Production Board, newly established in January 1942, surveyed every chemical manufacturer in the country. Factories with experience in fertilizer, mining explosives, and chemicals were now pressed into service. Hercules Powder Company, a firm with roots in chemical manufacturing dating back to the late 19th century, emerged as a key player. Its plants in Delaware and Pennsylvania had the infrastructure to produce nitrocellulose and other explosives. But even these facilities faced limits. Traditional production methods were too slow, and raw materials were too scarce. A radical approach was needed. The challenge extended beyond the factories themselves. Shipping, storage, and transportation networks were already stretched thin, and wartime conditions increased the risk of sabotage or accident. Each shipment of gunpowder had to be handled with meticulous care. Small errors could result in catastrophic explosions. Civilian workers, many women and teenagers drafted into industrial labor, were exposed to intense physical and psychological stress. They handled volatile chemicals, learned new techniques on the fly, and adjusted to 12-hour shifts under the constant hum of warning alarms and steam vents. Amid this pressure, innovation became the only path forward. Government chemists, military engineers, and private industry executives began to experiment with alternatives to traditional gunpowder. Some explored synthetic nitrates. Others considered entirely new propellants. In this environment of scarcity and urgency, even the simplest materials became potential solutions. Cornstarch, a humble household ingredient, drew attention. When combined with specific chemical treatments, it offered a surprising capacity to act as a combustible base. Scientists at Hercules recognized that if perfected, such a method could bypass the bottlenecks of conventional gunpowder production. As engineers sketched formulas on chalkboards and test batches were poured into vats, the stakes could not have been higher. Each day's delay meant fewer rounds for the front lines, and in a war that was already consuming thousands of lives daily, the pressure was existential. By the winter of 1942, the American public was largely unaware of the quiet revolution taking place in factories behind locked gates. The men and women in white coats and goggles were preparing to turn an ordinary agricultural product into a material that would arm a global army. This growing tension between raw necessity, technical possibility, and human labor set the stage for a remarkable chapter in industrial warfare. The solution would not emerge from the battlefield, but from chemistry labs and assembly lines, where cornstarch would become a lifeline for soldiers fighting thousands of miles from home. Hercules Powder Company was not a newcomer to danger. Its origins traced back to the breakup of DuPont's explosives monopoly in 1912, when Hercules emerged as one of the firms tasked with supplying industrial and military explosives to a growing nation. By the time America entered the Second World War, Hercules operated multiple plants across the Mid-Atlantic and Midwest, specializing in smokeless powder, nitrocellulose, and chemical intermediates used in mining and construction. What lacked was scale. Peacetime capacity had been sufficient for decades. Total war demanded something entirely different. In Washington, the War Production Board and the Army Ordnance Department moved quickly. Contracts were issued under emergency authority, bypassing traditional procurement timelines. Hercules was instructed not merely to increase output, but to rethink the entire production chain. Speed mattered more than elegance. Reliability mattered more than tradition. The question was no longer how gunpowder had always been made, but how it could be made with what America still had. The most critical shortage was cellulose suitable for nitration. Traditional smokeless powder relied on cotton linters, a byproduct of the textile industry. But cotton was now contested terrain. Uniforms, bandages, aircraft coverings, and medical supplies all competed for the same fibers. Imports were unreliable. Domestic supplies vanished almost overnight. Without cellulose, nitrocellulose could not be produced. Without nitrocellulose, modern gunpowder ceased to exist. Chemists at Hercules turned their attention to agriculture. The United States still possessed vast reserves of corn, produced in quantities unmatched anywhere in the world. Cornstarch, chemically refined cellulose extracted from maize, had long been used in paper manufacturing, adhesives, and food processing. What had never been attempted at scale was its transformation into a reliable explosive base. On paper, the chemistry worked. In practice, it was perilous. Cornstarch behaved differently from cotton when exposed to acids. Its molecular structure required modified nitration techniques, precise temperature control, and entirely new safety protocols. Early test batches produced unstable results. Some burned too slowly. Others decomposed unpredictably. Each failure forced chemists back to the drawing board, while military deadlines closed in. To meet the challenge, Hercules reorganized its workforce. Chemists, engineers, and production supervisors were embedded directly on factory floors. Feedback loops that once took weeks were compressed into hours. If a batch failed in the morning, the process was altered by nightfall. Accidents occurred. Fires flared and were extinguished. Entire production lines were shut down and rebuilt in days. The margin for error was narrow, but stopping was not an option. Meanwhile, the government expanded infrastructure to support the effort. New plants were financed with federal funds, constructed at unprecedented speed. Rail lines were rerouted to serve explosive facilities. Armed guards protected shipments. The secrecy was absolute. Workers were told only what they needed to know. To most Americans, the shells arriving overseas appeared no different than those used in earlier wars. Few understood how radically their contents had changed. By mid-1942, Hercules achieved consistency. Cornstarch-based nitrocellulose could now be produced in large quantities, meeting military standards for stability and performance. The Army Ordnance Department approved limited deployment. What began as an experiment became a cornerstone of America's wartime supply chain. The transformation was quiet, methodical, and invisible to the front lines. Yet behind every artillery barrage and rifle volley stood an industrial system that had reinvented itself under pressure. This was not merely a story of chemistry, but of people forced to adapt when failure was not survivable. And as production scaled and confidence grew, the implications extended far beyond the factory gates, into the lives of workers, commanders, and soldiers who would soon depend on cornstarch for survival. Inside the Hercules factories, the war was fought not with rifles, but with gloves, goggles, and white coats. Men who had once handled fertilizers or industrial chemicals now dealt with volatile mixtures that could explode in seconds. Women, who filled the labor gap left by men deployed overseas, moved through the plant with meticulous precision, monitoring gauges, stirring vats, and measuring powders. Their hands, roughened by long hours, executed complex chemical procedures that demanded unwavering attention. The pressure was relentless. Shifts stretched to 12 hours, often in freezing winter conditions or under summer heat, while alarms echoed through corridors signaling minor spills or chemical reactions that threatened entire production lines. Each worker bore the weight of the war on their shoulders. One miscalculation, one distraction could cost lives, either on the factory floor or thousands of miles away on the front lines, where soldiers counted on the ammunition being produced. Yet there was pride. There was urgency. Every successful batch meant lives saved and battles reinforced. Workers became acutely aware that their efforts were not abstract industrial labor, but a tangible contribution to the survival of their countrymen. The human cost was invisible to the public, but palpable inside the walls of Wilmington, where cornstarch, water, and acids transformed into gunpowder. The technological challenge was profound. Converting a humble kitchen staple into a reliable explosive required an unprecedented marriage of chemistry and engineering. Cornstarch's cellulose molecules were denser and less uniform than cotton fibers traditionally used for nitrocellulose. To nitrate them safely, engineers had to redesign reactors, introduce precise temperature controls, and create methods to prevent runaway reactions. Innovations emerged quickly. Continuous flow nitration systems replaced batch methods, reducing the risk of unstable decomposition. New acid ratios were calculated with exacting precision. Engineers devised neutralization tanks, washing systems, and drying protocols that minimized human exposure while maintaining quality. Sensors, valves, and steam jackets became essential for monitoring chemical reactions. though none could prevent accidents entirely. Every success represented a leap forward in chemical engineering. Cornstarch-based explosives were lighter, could be produced faster, and freed scarce cotton resources for other military uses. The process, once perfected, became a model of wartime ingenuity, an industrial solution to a strategic problem. At the front lines, the shortage of gunpowder had tangible consequences. Artillery units trained with fewer shells and infantry rifles often arrived with incomplete ammunition shipments. Bombers flew with partial loads of high explosives, limiting their impact on enemy fortifications. Every delay in production translated to diminished firepower and increased vulnerability for soldiers in combat. Once Hercules' cornstarch-based nitrocellulose came online, the effect was immediate. Artillery regiments received sufficient shell stockpiles for extended operations. Ammunition depots that had once warned of scarcity now held reserves. Soldiers noticed the difference. Training routines could be completed, missions could be planned with confidence, and battlefield commanders gained a new measure of strategic flexibility. This technological leap also allowed the military to experiment with new munitions. Lighter explosives meant more shells could be shipped per transport load. Engineers could explore innovative ordnance designs without the same concern for supply limitations. In effect, Hercules' adaptation extended the reach of American firepower, allowing the U.S. to project force more effectively across multiple theaters simultaneously. The human courage, chemical ingenuity, and tactical necessity all intersected here, creating a story of adaptation and innovation under intense pressure. Behind every soldier's gun, every artillery barrage, and every bomb dropped were the hands, minds, and machines of industrial workers thousands of miles away. At the highest levels, the challenge of replacing scarce gunpowder with a cornstarch-based alternative required vision, coordination, and decisive action. The War Production Board, under Donald Nelson, coordinated priorities across industries, ensuring that chemical companies like Hercules received raw materials, labor allocations, and technical support. Army Ordnance officers liaised directly with plant managers, establishing standards, safety protocols, and timelines that compressed months of industrial development into mere weeks. Company executives faced enormous pressure. Production goals were unprecedented, yet failure was not an option. Meetings ran late into the night, with engineers presenting test results and projections while military inspectors scrutinized every detail. Decisions had to balance risk and speed. Releasing an untested batch could be disastrous, but delaying production could cost lives overseas. Leaders had to trust their teams while remaining accountable to government authorities and the nation at large. This combination of industrial and military leadership created a new model for wartime coordination. Authority was shared across sectors, with scientists, executives, and military officers working side by side. The ability to mobilize quickly, adapt to setbacks, and maintain stringent oversight was as critical to the war effort as the explosives themselves. Though the Axis powers had no immediate knowledge of America's cornstarch innovation, the possibility of espionage and sabotage loomed constantly. Factories were guarded, shipment routes were monitored, and workers were often sworn to secrecy. The fear of enemy intelligence intercepting experimental production methods was real. Even a hint of vulnerability could be exploited, threatening both the lives of civilians and the effectiveness of military operations. Beyond espionage, the enemy's tactical actions indirectly pressured Hercules. Submarine campaigns in the Atlantic disrupted shipping, threatening supplies of sulfur, acids, and other chemicals essential for nitration. Every successful U-boat attack reminded engineers that their work was part of a larger global chessboard. Each day of delay increased the risk that American forces would confront German and Japanese armies without adequate munitions. In this way, the presence of a capable enemy intensified the stakes, driving innovation and vigilance within the factories. The transformation of cornstarch into explosives was not solely a technical achievement. It carried profound societal implications. Across America, civilians contributed to the war effort in visible and invisible ways. Farmers grew more corn, knowing that some portion would feed men and women fighting overseas, but another portion would literally power the weapons they relied upon. Women, teenagers, and older men staffed factories under grueling conditions, understanding that their labor could save lives at the front. Safety risks were ever present. Explosions, chemical burns, and long-term health hazards were part of daily life inside the plants. Yet workers endured, motivated by patriotism, peer pressure, and the shared sense that their work mattered in ways no paycheck could measure. Communities rallied to support these efforts, providing housing, transportation, and sustenance for the growing workforce. Local newspapers, while constrained by wartime censorship, celebrated the quiet heroism of industrial laborers, though the full scope of their contribution remained classified for decades. This societal dimension, the intersection of ordinary citizens and extraordinary circumstances, underscored the broader human cost of total war. Behind every technological innovation and tactical victory stood thousands of people whose courage, discipline, and sacrifice enabled success. The Cornstarch Gunpowder Project exemplified this principle. Innovation born not only from chemistry, but from the endurance and commitment of an entire society mobilized for survival. By the spring of 1942, Hercules cornstarch-based explosives were ready for the first full-scale production runs. The Wilmington plant hummed like a machine in perfect synchrony. Steam hissed from pipes, vats of nitrate cornstarch shimmered under industrial lights, and conveyor belts carried carefully monitored batches toward drying rooms. Every step had been redesigned for both speed and safety. Engineers wore multiple layers of protection, and floor supervisors monitored gauges with the precision of surgeons. On April 15, 1942, the first large shipment of cornstarch nitrocellulose rolled off the lines. Each crate was marked with codes denoting production date, batch number, and chemical composition. A tracking system devised to detect any deviation from specifications. Military inspectors, armed with chemical testing kits, verified that every batch met ordnance standards. The tension in the room was palpable. Any error could mean disaster. A volatile batch could ignite, destroying the plant and halting production for weeks. When tests confirmed stability and performance, a collective sense of relief washed over the staff. Engineers scribbled notes on adjustments for future runs, but the immediate priority shifted to deployment. The first batches were loaded onto reinforced trucks, guarded by armed personnel, and dispatched to munitions depots along the eastern seaboard. From there, the explosives would travel by rail and convoy to ports, eventually crossing the Atlantic in the belly of Liberty ships. The stakes of this success were enormous. Just weeks earlier, artillery units on the Pacific Islands had reported dangerously low ammunition. Infantry divisions in North Africa trained with only partial loads. Now, for the first time, the American military could anticipate a reliable, high-quality supply of gunpowder. Officers noted in memos that the arrival of these new explosives would allow for extended campaigns without the crippling delays previously caused by shortages. Production was not without danger. Early runs required constant recalibration. Some batches exhibited minor instability, and engineers worked round the clock to refine acid ratios, drying times, and temperature controls. One early mishap in late April caused a small fire in a drying chamber, fortunately contained without injuries. But it reinforced the lesson that the line between innovation and catastrophe was razor thin. Across the plant, workers felt the significance of their labor. Every stirring of the cornstarch slurry, every measurement of acid, every inspection of drying sheets was part of a chain that could determine the outcome of battles thousands of miles away. The monotony of repetitive industrial labor was punctuated by the weight of responsibility, a silent, pressing knowledge that their work could save lives or fail catastrophically. Meanwhile, the military began integrating the first shipments into existing stockpiles. Ordnance officers reported improvements in storage stability and handling safety. Shells loaded with cornstarch-based nitrocellulose burned consistently, producing the same range and explosive force as conventional gunpowder. Field commanders, initially skeptical, confirmed in confidential telegrams that ammunition performance met expectations. By May 1942, Hercules had reached an unprecedented production tempo. The Wilmington plant operated 3 shifts daily, and satellite plants in Pennsylvania were ramped up to mirror its output. The transformation of a kitchen staple into a weapon of war was complete. What had once been a humble ingredient was now a critical component of America's industrial artillery system. The first deployment marked a decisive moment. Engineers, chemists, and factory workers watched as crates were loaded onto ships bound for distant theaters of war. In the laboratories and offices of Hercules, the war's abstract pressures, shortages, deadlines, and logistical constraints became tangible and solvable. For the first time, the nation could see that scarcity did not have to dictate defeat. The success of these initial shipments set the stage for full-scale implementation, a process that would ripple across the military and reshape America's capacity to sustain a global fight. The triumph of ingenuity, coordination, and human perseverance had transformed a logistical nightmare into a powerful industrial asset. By the summer of 1942, cornstarch-based nitrocellulose was no longer an experiment. It was policy. The Army Ordnance Department formally authorized its use across multiple categories of ammunition, from small arms cartridges to artillery propellants. Inspection teams rotated through Hercules facilities weekly, verifying batch consistency, storage behavior, and burn characteristics. Reports were clinical, unemotional, and decisive. Performance matched or exceeded traditional formulations. With approval secured, production surged. Hercules expanded drying houses, acid recovery systems, and waste neutralization units to sustain round-the-clock output. New workers were trained in days rather than months. Process manuals were rewritten in real time as refinements emerged. Every modification was documented, tested, and cleared for immediate use. This was industrial warfare at full throttle. Shipments moved faster now. Rail cars left factories under armed escort, routed directly to shell-loading plants and naval ordnance depots. From there, ammunition flowed outward to North Africa, where Allied forces prepared for sustained operations against Axis positions, to the Pacific, where Marines required constant resupply to hold contested islands, and to Britain, where American stockpiles supported the slow buildup toward a future invasion of Europe. The battlefield feedback was unmistakable. After-action reports noted no degradation in reliability. Artillery units fired longer barges without supply interruptions. Training commands increased live-fire exercises, confident that ammunition could be replaced. Logistics officers recorded improved predictability in delivery schedules, a quiet but decisive shift. War was not won by innovation alone, but innovation removed a fatal weakness. Not every challenge vanished. Cornstarch-based explosives required careful humidity control during storage, particularly in tropical climates. Hercules engineers worked directly with ordnance officers to adjust packaging and desiccation methods. Problems were addressed methodically, without panic. By late 1942, these issues were largely resolved, folded into standard operating procedures. Behind the scenes, federal oversight intensified. Accident reports were scrutinized. Environmental hazards were mitigated where possible. Production quotas climbed steadily, measured not in pounds, but in tons per week. By the end of the year, cornstarch-derived nitrocellulose accounted for a substantial share of America's explosive output, a figure that would have been unthinkable just months earlier. What made the moment decisive was not a single explosion or battle, but continuity. For the first time since entering the war, the United States could sustain prolonged combat without fearing depletion of its most basic resource. This stability reshaped strategic planning. Commanders could now think months ahead instead of days. Industrial bottlenecks no longer dictated battlefield tempo. Inside the Hercules plants, the urgency shifted subtly. The initial terror of failure gave way to disciplined routine. Danger remained, but confidence grew. Workers understood that what they had built was durable. The war still demanded sacrifice, but the system now worked. The turning point had passed. The question was no longer whether America could arm itself, but how far its industrial momentum could carry it. And as factories continued to convert grain into gunpowder, the consequences of that momentum began to spread far beyond the production lines, into the balance of power itself. That balance would become fully visible in the months and years that followed, as the war absorbed the output of these factories and revealed what this quiet industrial victory had truly achieved. By the end of 1942, the Hercules Cornstarch Initiative had reshaped America's munitions landscape. Production figures reflected an extraordinary turnaround. Where once the U.S. had faced critical shortages, factories were now delivering thousands of tons of nitrocellulose every month. Artillery units, previously constrained by intermittent supply, now received consistent shipments, allowing for prolonged campaigns in North Africa and the Pacific. Rifles, machine guns, and mortars were fully stocked. Bombs for naval and aerial operations were reliably armed. Military dispatches from the front lines captured the effect with restrained but unmistakable appreciation. A commander in the Solomon Islands noted in June 1942 that his artillery batteries had no gaps in supply for the first time since arrival, while North African units preparing for Operation Torch would soon benefit from fully loaded depots. These reports, though concise, were profound. Lives that might have been lost to empty shells were now supported by an industrial lifeline born in the American heartland. The human cost within factories was significant. Despite stringent safety protocols, incidents occurred. Small fires, chemical burns, and near explosions were recorded in internal logs. Every worker faced the risk of catastrophe in exchange for the broader war effort. Yet morale remained high, fueled by the awareness that their labor directly affected the survival of soldiers overseas. Many workers, particularly women and teenagers, took pride in the knowledge that a simple agricultural product, corn, had been transformed into a weapon that would alter the course of battles. Industrial managers and engineers also experienced the toll of relentless production. Equipment ran constantly. Maintenance crews were stretched thin, and oversight demanded unwavering attention. Any lapse could halt the entire chain of supply. Yet, by enforcing strict quality control and meticulous documentation, Hercules maintained output without major interruption. The company's ability to sustain high volume, safe production became a model for other wartime manufacturers facing similar resource constraints. Strategically, the success of the cornstarch-based explosive allowed American forces to plan campaigns with confidence. In logistical reports, the Ordnance Department began to project supplies 6 months in advance, a task previously impossible. Naval operations, air raids, and artillery barges could now be executed with a reliability that directly influenced tactical decisions. The psychological impact on commanders was subtle but critical. Scarcity no longer dictated risk, allowing bold strategies to be attempted with measurable odds of success. Beyond the front lines, the initiative strengthened the broader war economy. Corn that would otherwise have been consumed as food, industrial filler, or livestock feed was now a critical raw material. Supply chains for acids, stabilizers, and processing chemicals expanded, creating new jobs and stimulating regional economies. Wilmington, Delaware, became a hub of innovation and production, its industrial output vital to the Allied war effort. The first phase of aftermath concluded with a clear lesson. Resourcefulness, coordinated effort, and human perseverance could overcome even the most acute shortages. Hercules had demonstrated that necessity could drive innovation, turning a humble crop into the engine of industrialized warfare. The full impact of Hercules' cornstarch-based explosives extended well beyond 1942. By 1943, production lines had reached full scale, and the United States no longer faced crippling shortages of gunpowder. Every theater of war benefited. Artillery barges became sustained, naval shells were plentiful, and small arms units never lacked ammunition. This reliability allowed the U.S. military to plan extended campaigns with a confidence previously unimaginable, fundamentally altering operational strategy. The chemical industry itself underwent a quiet revolution. Techniques developed to nitrate cornstarch laid the groundwork for broader applications in explosives and materials science. Continuous flow nitration processes, improved temperature and humidity controls, and safety protocols pioneered during this period became standard in peacetime chemical manufacturing. Hercules' methods demonstrated that industrial ingenuity could overcome raw material constraints, inspiring similar innovations in petroleum-based propellants and synthetic explosives. Workers and engineers who had risked their lives on the factory floor became unsung heroes of the war effort. Their labor demonstrated the human capacity to adapt under extreme pressure, blending meticulous attention to detail with the urgency of a national crisis. Communities around Wilmington, Delaware, and other production hubs felt the social and economic effects. Job creation, regional economic growth, and a collective sense of contribution to the war effort. Yet the dangers remained. Industrial accidents, long hours, and exposure to chemicals left lingering effects on many who had participated, a silent reminder of the personal sacrifices underpinning national success. Strategically, the Cornstarch gunpowder program sent a message beyond the battlefield. It demonstrated to Allied and Axis powers alike that the United States possessed not only the industrial capacity, but also the adaptive ingenuity to overcome severe shortages. The innovation helped cement America's emerging role as the arsenal of democracy, capable of supplying itself and its allies with munitions at an unprecedented scale. Even after the war, the legacy endured. Chemical engineers carried forward the techniques refined during wartime, influencing explosives, propellants, and industrial chemistry for decades. Hercules Powder Company gained prestige for its technical contributions, and the methods pioneered in 1942 continued to inform both military and civilian chemical processes. More broadly, the episode became a symbol of the ingenuity, coordination, and sheer determination that characterized the American war effort, a reminder that industrial problem-solving could tip the balance in global conflict. The story of cornstarch gunpowder was more than a tale of innovation. It was a lesson in resilience. In a world where resources were scarce and stakes were life and death, ordinary materials and human labor combined to meet extraordinary challenges. What began as a wartime emergency ultimately reshaped production methods, strategic planning, and chemical engineering itself. The next step is a reflective, philosophical conclusion, a calm yet emotionally grounded closure connecting human ingenuity, sacrifice, and historical significance. In the quiet of Wilmington's factories, amid the hiss of steam and the smell of nitrate cornstarch, a profound truth about human ingenuity was revealed. War, in its urgency and brutality, forced people to confront limits of materials, of technology, of endurance. And in doing so, It often revealed capacities previously unimagined. Ordinary corn, a staple of American farms, became a linchpin in global conflict. Simple human labor, disciplined and relentless, transformed it into a substance that could shape battles and save lives. The story of Hercules Powder Company illustrates more than chemistry or production. It is a testament to coordination under pressure. Government agencies, military planners, industrial engineers, and factory workers converged with a singular purpose. Each decision, each adjustment, each hour of labor had consequences that rippled across oceans. The victory was not measured in headlines or medals, but in tons of explosives that reached the front lines precisely when they were needed. There's a quiet heroism in such work. The women and men who handled dangerous chemicals, calculated acid ratios, and endured long shifts did so without fanfare. Their courage was steady, practical, and often invisible. Yet their contribution shaped the course of the war, proving that innovation is not only born in laboratories, but on factory floors, in ordinary towns, under extraordinary pressure. Historically, the Cornstarch gunpowder program reminds us that the outcome of conflict often hinges on ingenuity, adaptability, and human perseverance as much as battlefield valor. It underscores the interconnectedness of science, industry, and strategy, and the profound impact that seemingly small innovations can have on global events. Ultimately, the transformation of cornstarch into explosives is more than a story of wartime necessity. It is a story of resilience, creativity, and determination. It demonstrates that even in scarcity, humanity can find solutions. And in that process, ordinary lives, farmers, factory workers, engineers, left an extraordinary mark on history, a quiet but lasting echo of courage, intellect, and relentless resolve.